You're good. All right, laws of exponents. Everything that we are doing today, you have already learned in Algebra 1, Algebra 2. And if you've already taken college algebra. If you're in it right now, you learned this in the beginning of last semester. And if you haven't taken it, you still learned it in Algebra 1 and Algebra 2. So I'm going to kind of go quickly to review all these things. And then we are going to take notes in our notebooks that we haven't touched since January. So first thing, laws of exponents for all non-zero real numbers, a and b, those are your bases. And rational numbers, m and n, those are your exponents. If they have a same base and you are multiplying, what do you actually do to the exponents? You add them. So if I have x to the fourth times x to the third, what is that going to be? 4 plus 3 is x to the seventh. Now what if this had a coefficient out front? What are we going to do to the coefficients? Multiply. So just as a reminder, you're going to multiply the coefficients, add the exponents. Multiply the coefficients, add the exponents. What about dividing? What do I actually do when I'm dividing? Subtract. So x to the 6th over x squared is x to the 6th minus 2, which is x to the 4th. Again, what if there are coefficients? What do you do with the coefficients? Divide. So you are going to divide your coefficients and subtract your exponents. Yes, and we're going to get into that. But yes, you can still add and subtract negative exponents. Yep. Well, yes and no. Your final answer, they can't be, but you will have negative exponents. All right, what if you have these same exponents but different bases? So you have ab raised to the m. What are you going to do here? You are going to distribute it to both of them. A to the m, b to the m. Y'all do very good when I give you something like this. What is xy to the 8th? x8, y8. You're like, duh. Here's where you struggle. What if I give you 2x to the 3rd? What is that? What do you think people say instead of 8x to the 3rd? People say 6x to the 3rd. Why is it not 6x? Because you have to do 2 to the 3rd power. Don't do 2 times 3. 2 to the 3rd power. And what's 2 times 2 times 2? 8x to the 3rd. Does that make sense? You're going to hear me say this a lot, but when in doubt, expand it out. If you don't know what to do, if you didn't know to divide those, expand out. Draw 6x's and 2x's, cross them out. What's left? Right here, you could draw 2x, 2x, 2x 3 times, and then just multiply. 2 times 2 times 2. So when in doubt, expand it out. A over b to the m, you just distribute that exponent to both of them. So if I have x over y to the 8th, x to the 8th over y to the 8th. Can I cross these out? Can I subtract these exponents? No. Why not? They are not the same base. They have to be the same base for you to cross them out. A little caveat I want you to write down off to the side over here. A plus b to the m is not a to the m plus b to the m. Why not? You have to FOIL. Look up real quick. Look up, y'all. These are not the same. This has a plus. This does not. You can distribute this. You cannot distribute this. An example of this would be like a plus b squared. What is a plus b squared? Do you see how if you just distribute that and make a squared plus b squared, you're missing that whole middle term? So please be careful. This right here is foiling. And for some reason, y'all just forget to do that. Last but not least on this section, power of a power. A to the m raised to the n. What do you do with these two exponents? Multiply them. So if you have x squared to the third, what are you going to get? What are you going to get? X to the sixth. Just multiply your exponents. Do I have any questions so far? Anything to the 0 power is 1. So 2,543 to the 0 power is 1. Anything. All right. Gabby asked about negative exponents earlier. If you have a negative exponent, it cannot be in your final answer. So how do I get rid of it? Move it to the denominator and make it positive. So if I have x to the negative 2, what is that equivalent to? 1 over x squared. Move it to the denominator, make it positive. And there's nothing with it, so you just leave it 1. What if I have x, y to the negative 3? If it's with something, that stays up top, and you just move only the negative to the denominator, not both of them. And then last but not least, what if I have r squared over z to the negative 3? What if my negative is in the denominator? Move it to the numerator. So if your negative's in the numerator, move it to the denominator, make it positive. If it's in the denominator, move it to the numerator, make it positive. Questions? All right, a to the 1 over m. Whenever your exponent is a fraction, that denominator is your root. So a to the 1/2 is what? Square root of a. A to the 1/3 is what? Cube root of a. Now that's if there's a 1 in the numerator. What if there's not a 1 in the numerator? Your denominator is still your root. What is your numerator? Your exponent or your power. So if I have x to the 2/3, how would I write that? The cube root of x squared. Or I could write the cube root of x and put the square outside. It doesn't matter which one you write it. By the way, I do not necessarily have a preference. You can leave it as a fraction or you can leave it as a root. It does not matter to me. Okay? The bottom 4 are just saying that if something's inside a square root, you can separate it. If two things are inside a square root dividing, you can separate the roots. And the same thing if it's a cube root, a fourth root, any type of root, you can do that. Okay? All right. On the back of this is logs notes. We're not going to do this till next week after our test, so we're going to skip that today. And then you can see worksheet 1. Worksheet 1 is what your homework is tonight. It is not going to be for a grade. The answers are going to be in Schoology. However, when you come to me and you're like, Miss Olivares, is there a review? Welcome to worksheet 1. All right, worksheet 1 has 50 problems for you to review with. I will tell you, 11 of these are on your test. So there are test questions on here. All right. If you can move the blue packet to the side and get out your notebook. We haven't used this thing since January. Yes. No. Yeah, if you want, if you're comfortable with that. I have notebook paper back there too. But yeah. All right. Simplifying exponents is page 28. We have 9 examples to get through. I have about 28 minutes. So, y'all ready? No, I have a headache. She said, I'm ready to sleep. All right, 9 examples is what we're doing today. So, example number 1 is negative 5x to the third y to the negative 4 squared. Negative 5x to the third y to the negative 4th squared. How are we, and by the way, I'm going to show extra work just because this is notes so you can see what I'm doing. I do not need you to show every step that I'm showing on your quiz, which you have a quiz over this on Thursday. All right, so what do I do? Distribute. I'm going to distribute this squared to every single excuse me. Term's not the right word. Variable, but they're not all variables, so. And this is a perfect example of if you didn't show this step, you would be fine. What is negative 5 squared? 25, boys. Shh. What is x cubed squared? And what is y to the negative 4th squared? Which gives me, is that my answer? Why not? You cannot have a negative exponent in your answer. And by the way, I'm just going to write some notes off to the side. You cannot have a negative exponent in your answer. So what's my answer? Bless you. What do you notice my example has on every single line? Equal signs. You will need an equal sign every single line or you will get points off. All right, I want you to do example 2 on your own. (24x to the 7th y squared) divided by 4x y to the 5th. Go. All right. What did you do here? What do we do first? Divide the coefficients. And then what did you do? Subtract the exponents. 24 divided by 4 was what? 6. And then there's an invisible 1 right there. What is 7 minus 1? And 2 minus 5? Negative 3. Is that acceptable? Nope. So my answer is 6x to the 6 over y to the third. Questions? Example 3 is 2x y to the negative 2 cubed times 3x to the negative 2 y to the fifth squared. Be careful. What's 2 cubed? 8. X cubed. And what is y to the negative 2 cubed? Negative 6. Thank you. And then what's 3 squared? 9. Make sure you're not saying 6 on both of those. And then I get x to the negative 4, y to the 10th. What am I going to do next? Louder? Multiply the coefficients and add the exponents. What is 8 times 9? That gives me 72. X to the negative 1, y to the negative 6 plus 10 is 4. Is that acceptable? What questions do I have? We're okay? Is any of this new? No. Two x cubed over 3y to the negative 1, all raised to the negative 3. What would you do here for this problem? Say it again. I don't dislike it. Distribute, I don't dislike it. Both of those are good options that you can do. I am not going to do them for my notes, but if you did those, you would not be wrong. I'm going to do something else. Anybody want to guess? I want to get rid of this negative before I do anything. How can I get rid of that negative with the 3? Y'all are whispering, but speak louder. How do I get rid of this negative with this 3? I can just flip my fraction. So instead of, is that what you said? No? Oh, yes. So instead of having this, I'm going to put 3y to the negative 1 up top and 2x cubed on the bottom. And now this is going to become a positive 3. That negative out front, you can just flip that fraction. I think it makes it easier to solve. Could you distribute it right in the beginning? Yes. But I think this makes it easier. Now I'm going to distribute. What is 3 cubed? What is 2 cubed? And what is x cubed to the third? Say it again. X to the 9. Is that acceptable? No. So what's my answer going to be? Questions? Are we okay? All right. I'm going to have you do the next two on your own. Y'all ready? Can I change this? Oh man, I just went off my color scheme completely there. Example 5 and 6, I'm actually going to put right next to each other just because they are very similar in looks. All right, I'll give you a song to solve these. Not that one. No, it should be coming on. Oh, I have a headache. Good job. Yes. Yes. All right. So, did you get the same answer or different answers? The same answer or different answers? We should have gotten different answers. Why should we have gotten different answers? This is adding. What is this doing? Multiplying. All right. When you add, what should your first step be here? Can I add these together? No, they're not like terms. So, what your first step when you add is, I will say, you could have done GCF with this, right? If you did GCF, that's okay. However, I do want to let you know, GCF will not always work. So, what I want you to do here is separate. Separate. So, I have 12x cubed over 3x cubed. And then I have 9x to the 5th over 3x cubed. What do I do now? Divide. What is 12 divided by 3? 4. And what happens to x cubed over x cubed? What is 9 divided by 3? What's x to the 5th over x cubed? And that's your final answer. Did y'all get that? Okay. What about this one right here? What am I going to do here if it's multiplication? Y'all, do not separate. Because if you do, then you are squaring the denominator on accident. You cannot separate them if it's multiplication. Just multiply. Multiply the big, add the little. What is 12 times 9? 108. And then what's x to the 3rd times x to the 5th? Over 3x cubed. Now what? Does anybody know what 108 divided by 3 is? 36. And what is x to the 8th over x cubed? Do you see the difference in these? Yes. Okay. Yes. They do have the same base. Their base is x. The number in front is a coefficient. Yeah, so if it wasn't, like if this was x and this is y, you couldn't multiply them. But they do have the same base. Does that make sense? Yeah. Bases with the exponent. Okay. All right. For example number 7, y'all, I have about 10 minutes in class and we have 7, 8, and 9 to do. For example 7, there are 2 ways that you can do this, but I want you to star this because you're going to see this on your quiz on Thursday. You're going to see it, worksheet 1, a couple of times. You're going to see it on your homework that's due Thursday. You're going to see this on the test that's next Tuesday. You're going to see this on the assessment that's in 3 weeks. This question is going to come up a bunch. Don't be the person that misses it every time. Okay? So I put a star next to it. X to the negative 2 plus y to the negative 2 to the negative 1. What do you think everybody tells me to do? I like it. They tell me to distribute this. Boom, boom, x squared plus y squared. Solved it. But what did we say over here that we cannot do? We cannot just distribute it because there is a plus sign. So, do you know how to FOIL negative 1? Not quite. So we're going to leave that alone for right now. How do I deal with x to the negative 2? That is 1 over x squared. How do I deal with y to the negative 2? 1 over y squared. By the way, have you been doing your equal signs? Okay. Now, everybody wants to tell me, flip it back, the negative, you're done. Again, you still can't do that y. There's a plus sign. So what would I do next to help us? Say it louder. You have to find a common denominator. So if this one's x squared and this one's y squared, what do I multiply this by? I'm going to multiply both of these by y squared. And what am I going to multiply this by? X squared. So that gives me y squared plus x squared all over x squared plus y squared. Do you agree with that? I did 1 times y squared, x squared, y squared. X squared times 1, x squared, y squared.
Wouldn't it be x squared times y squared on the bottom?
Yeah. Oh, sorry. I didn't even realize I put plus. My bad. That's supposed to be times. Did I say it? Did I say x squared, y squared, or I said plus? Or you don't know? Okay. Times. Sorry. Sorry. Thank you for correcting that. Y squared plus x squared over x squared, y squared to the negative 1. Does that make sense? Now what can I do? Now I can get rid of this negative 1 by how doing what? Flipping it. X squared, y squared over y squared plus x squared. And actually that's my answer. I'm done because it's to the 1, which is just not. Does that make sense? Yes, no, maybe so? I highly recommend worksheet 1. Where is it? Number 11. You're going to see it again. Highly recommend you looking at that. Actually, 8, 9, 10, and 11 are all the same concept. Okay? So that's just extra practice again. All right, example 8. This one's fun. X to the negative 1/3 minus 3x to the 2/3 over x raised to the negative 4/3. By the way, all those are exponents. I don't know if they look like it, but they are all exponents. What would you do first here? What are you going to do first? Don't do that. Don't do that. You have a minus in between them. What would you do? Separate them. So I'm going to make this x to the negative 1/3 over x to the negative 4/3 minus 3x to the 2/3 over x to the negative 4/3. Now what are they doing? What are these doing? Dividing. And so when we divide, what do we actually do to our exponents? So what is negative 1/3 minus negative 4/3? And what is 2/3 minus negative 4/3? Do I need to zoom in? Yeah, so they end up adding, what is negative 1 plus 4? 3. And what's 3 divided by 3? So this is just x. Does everybody see what I just did? Okay, be careful. A lot of y'all forget to do minus the negative. Same thing right here. This is going to be minus 3. What is 2 plus 4?
6.
Divided by 3? So this is x squared. And that is your answer. And that's it. Okay, just because it's fractions, do not get nervous. You're doing the same thing. All right, example 9 is our last example. It's a lot like what we just did. What are you going to do here? Distribute. When you multiply exponents, what do you really need to do? Add them. Tomorrow we'll solve exponents, and then I believe Wednesday we do graphing and a quiz. A quiz is Thursday. I think tomorrow hopefully we'll have some homework time. Hopefully. If you need extra practice, start working on worksheet 1.